Typing exhaustive, step-by-step instructions every time you analyze data wastes valuable time. We'll replace that repetitive prompting with one single command. The solution is an agent skill, a reusable folder of instructions formatted in an open standard. Today, we will build one specifically for time series data analysis. To follow along, you need three things: the Claude Code command line interface, an Anthropic API key, and a local sample CSV file. By the end of this tutorial, you will have turned your general-purpose AI into an on-demand data analyst that runs entirely from your terminal. This diagram shows the architecture of multi-agent reasoning. We must define how our agent structures its execution cycles. Option 1 is sequential prompt chaining. One agent finishes its output, feeding directly into the next agent. Option 2 is parallelization. You use this for speed. The workflow is sectioned out so multiple agents analyze different data simultaneously. Option 3 is the orchestrator workers pattern. A central director agent dynamically activates specialized subskills only when needed. Our time series analysis skill will use this orchestrator pattern. The orchestrator architecture scales effectively. It only deploys specialized instructions when a task actively demands them, which prevents the main AI from being overwhelmed by a massive list of background rules. Step 1. Create a dedicated directory for your skill. Inside that new folder, generate your foundational text document, the skill.md file. This setup relies on progressive disclosure. This is how the agent manages its limited context window, preventing memory overload. It does not load the entire skill right away, keeping only the skill's name and a short description in its active memory. When the orchestrator matches a user prompt to that specific description, the full, dense markdown instructions are finally disclosed and loaded into the active context window. You need to write a highly specific, trigger-focused description at the top of your skill.md file. Tell the AI to trigger this file whenever asked to analyze time series CSVs. Progressive disclosure keeps your context window clean. Loading instructions only when they match your prompt preserves the memory needed to handle the actual data analysis. Next, take your analyze.py script, the file containing your core pandas logic, and place it directly into your new skill folder. On its own, the agent cannot run Python natively. It only reads and writes text unless you authorize it to use external execution tools. Inside your skill.md file, write instructions that command the agent to use its built-in bash tool to execute your Python script. You also need to authorize file system access. The agent requires this permission to read your source CSV and retrieve the resulting output from the script. A skill without tool permissions is just a text document. Bridging the agent to a file system environment transforms written instructions into an active automated workflow. Now we run it. Open your terminal, launch Claude Code, and type your natural language trigger. Analyze the sales.data.csv using the time series skill. In step 1 of the execution sequence, the orchestrator reads your prompt and scans the available skill descriptions in its memory. Step 2, the orchestrator matches your intent to the time series skill and progressively loads the full markdown instructions into its active memory. Step 3, the agent reads those instructions and autonomously invokes its bash tool to execute your Python script against the target dataset. Finally, the agent reads the terminal output logs generated by the script and synthesizes that raw data into a cohesive summary. Orchestration, progressive disclosure, and tool permissions combine to automate the logic. The agent performs every step, from matching the intent to summarizing the logs, without requiring a human to prompt the next move. This is our final result. We have a beautifully formatted, statistically accurate time series data report generated directly inside the terminal window. Because this skill folder relies on an open standard, it is highly portable. You can share this directory with your teammates and deploy it across any skills-compatible agent immediately. Your next step is to practice extending this workflow. Try adding a parallelized instruction to your skill that generates visual charts alongside the text summary. Packaging these repetitive workflows into reusable agent skills gives your agent the specific instructions it needs to execute technical tasks independently. Subscribe to the channel for more guides on building specialized agentic workflows.